In this video, we are going to summarize the topic photoelectric effect based on the examination guideline. And if you look at the big examination guideline which I've posted earlier, the very first thing we are required to know is the definition of photoelectric effect. And photoelectric effect is a process, keyword is a process whereby electrons are ejected from the metal surface when light of suitable frequency is incident on the metal surface. So in defining this, we should make sure we use the keywords here. This is a process whereby electrons are ejected from the metal surface if a light of suitable frequency is incident on it. Here we are concentrating on light, but actually you can observe photoelectric effect in all the electromagnetic radiations. And let me remind you of the electromagnetic radiations. In the electromagnetic radiations we have the radio wave, the microwave, the infrared, the visible light, the UV, X-rays and gamma rays. And the easiest way electromagnetic radiations, the easiest way in which you can remember the order of the electromagnetic radiation is by saying roommate is visible until Christmas gift. The roommate is visible until Christmas gift. It's a way you can remember it very easy. In other words, we have the radio, we have the microwave, we have the infrared, you have the visible light, you have the UV, and you have the X-ray, and you have the gamma rays. And it's very, very important we know that in the case of the radio wave, it has the highest frequency, the highest wavelength. You have the highest wavelength. So what are we saying? As you move from the left going towards the right, you will see that the wavelength decreases. And we know the relationship between the wavelength and the frequency. They are inversely proportional. So in other words, if the wavelength is decreasing, it means that as we move from the left to the right here, it means that the frequency increases. So that means that the radio wave is having the highest wavelength, while gamma rays have the highest frequency. And another important thing we're supposed to also to know on this photoelectric effect is the significance. In other words, why are we studying this photoelectric effect? And you can see that photoelectric effect, this is according to examination guideline. I've finished with this. I'm trying to summarize the topic so that we'll get all the information we need to know at a very short period of time. The significance. And the significance of photoelectric effect is that it proves quantum, it proves the quantum theory. And what is the quantum theory talking about? Quantum theory is talking about that the light consists of, it's talking about the light that they consist of packets, that the light consists of packets of energy. And those packets of energy, each of them, the energy they carry is the same. In other words, that the packets of energy, they are quantized. We call them quantum. The energy which each of those packets of energy carries are quantized. But we have a special name. We call them photons. So the energy of each of the photons, the energy they carry is quantized. And in other words, we can easily calculate the energy that each of those quantum have. We can easily calculate it if we know their frequency. If you remember our electromagnetic radiation spectrum here, once the frequency is known, we can easily calculate the energy. And from this formula, we can see that our H here, which we call the Planck's constant, it's called the Planck constant, 6.63 times 10 raised to power 34 joules seconds. It's a constant. So, and also we can also calculate it using, two of them are constant, and so if we know the frequency, we can easily calculate it. If we know this, we can easily calculate it. Remember, the speed of light is given 3 exponent 8, the speed of light. So in other words, we can easily calculate the amount of